Washington looks peaceful, but it may be one of the most geologically dangerous places in America. In 2026, scientists are tracking new signs of volcanic unrest beneath Mount St. Helens, deeper magma movement under the Cascade Range, and growing concern over the massive fault system off the Pacific coast. At the same time, new research is revealing how this state was shaped by some of the most violent natural events in North American history: megafloods, eruptions, earthquakes, and sudden landscape collapse. So this isn't just a story about one volcano. It's about a region where fire, water, and tectonic pressure are all still at work. From magma rising below the Cascades, to the Cascadia Fault offshore, to ancient floods that tore eastern Washington apart, the ground here has never really been still. And the more scientists uncover about Washington's past, the more worried they are about what could happen next. Mount St. Helens, a volcano reborn in silence. Mount St. Helens, a name spoken with awe and caution. The memory of 1980 remains sharp. A mountain gone in a moment, forests leveled, sky turned to night. Yet while that eruption forged its infamy, few realize Mount St. Helens has never been truly dormant. In 2026, new eyes and sharper instruments return to this battered summit, and the signals are clear. The mountain lives, and beneath its scarred dome, things are stirring. For months, tremors ripple through the region. Networks of seismometers register persistent quakes, some sharp and staccato, others low and rumbling. Deep underfoot, sensitive instruments record subtle shifts. Magma, once considered stagnant, is migrating upward, recharging the system beneath. This is not the heedless violence of 1980, but a measured, patient rebuilding. A process as slow as it is inevitable. Within the Horseshoe Crater, the lava dome, fractured and rebuilt for decades, is shifting again. Repeated surveys measure subtle changes, bulges and new cracks. Faint warmth seeps through vents at night. From the rim, researchers have observed early morning steam, wisps rising ghost-like above the dome. Dozens of new gas vents mark points where hidden chemistry meets the world above, releasing sulfur-rich vapors and heat. What unsettles scientists is what's missing. There has been no eruption, no towering ash column, just patient, persistent change. Magma rises, the ground swells, gases creep out, but the volcano has not broken through. It is a living system anticipating a future act, the slow choreography of recharge ticking on under forested slopes. Could this volcano, once the paradigm of sudden violence, instead become an expert of waiting? Or does this long silence precede another kind of warning? A recalibration before renewed fire? Residents living in the volcano's shadow report distant, low rumbles, especially at dawn, and note subtle changes in animal behavior. Scientists watch for changes via advanced sensors and gas analyses, scrutinizing vent emissions for fluctuations in carbon dioxide and sulfur dioxide, which might betray new unrest below. The mountain is monitored as a patient in critical condition, constantly analyzed, closely watched, yet always cloaked in enigma. And as Washington's most watched volcano quietly rebuilds, another question emerges. What else is stirring beneath the green cathedral of the Cascades? The hidden networks, magma highways beneath the Cascade Range. The Cascades ridgeline sweeps impressively across Washington, a range forged where continental plates converge. For years, volcanologists considered each of these peaks, Mount Rainier, St. Helens, Adams, and others, an isolated entity, each powered by its own magma. In 2026, that idea morphs. Advancements in imaging, radar, seismic, chemical tracing now depict the deep crust as a network, not a collection of volcanic islands. The latest research unsettles old assumptions. Instead of distinct magma bodies, evidence indicates a complex, interconnected magma system beneath the Cascades. Here, Molten rock travels not only upward to fuel individual volcanoes, but laterally through fractures, conduits, and partial reservoirs. These magma highways link volcanic fates and hint that unrest at one summit could transfer stress and energy across the entire arc. Under Mount Adams, the state's largest volcano by area and volume, early signs of waking emerged in 2026. Persistent, faint quakes began to register from miles deep, sounding like ice breaking up in spring. Drone-mounted magnetometers detected faint anomalies, hinting that hidden magma masses were shifting where the eye cannot follow. Digital models, rendered in electrifying color by new supercomputers, reveal shifting blobs below ancient summits, fading in some places, intensifying in others. The recharge at St. Helens appears on these virtual maps as just one patch amid a vast, simmering quilt. The suggestion is momentous. The solitary peaks above cloak a tangled, churning underworld below. Could an eruption at one volcano influence activity at its neighbors? Are these systems interlinked so deeply that strain, once great enough, might set off a volcanic relay? Researchers debate the extent and importance of these connections. Some see the possibility that pressure changes might ripple across the arc, subtly altering eruption risk across multiple peaks at once. The region's hazard plans are adapting. Agencies now monitor the entire range for synchronous pulses, scanning for faint hints of coordinated activity. Beyond the mountains, though, lies an even stronger force that once changed everything. Not volcanic fire, but glacial flood. Floods from the ice, the cataclysmic story of the Missoula Floods. Look east, and Washington seems otherworldly. Land gouged and shredded, canyons opening out of rolling prairie, cliffs rising hundreds of feet above cracked ground. This is the Channeled Scablands, long a geologic puzzle. Thanks to new surveys and fieldwork in 2026, the answer seems clearer and more profound. This landscape was carved not by slow rivers, but by overwhelming floods at the end of the last ice age. The culprit was ancient Lake Missoula, a glacial lake dammed behind an ice wall, repeatedly bursting free when that dam failed. Each failure unleashed a flood of unimaginable energy. Water hundreds of feet deep, moving at highway speeds, crashing across the eastern state, gouging the land down to bedrock in a matter of days. Work in 2026 pushed the understanding further. New mapping traced immense, wave-shaped ripple marks, hills higher than a house, and sediment layers within ancient channels. The evidence reveals that a single flood could not explain the landscape. Instead, dozens happened, each scouring the land, each separated by intervals in which rivers re-established themselves, only to be erased again. At places like Dry Falls, once considered an outsized curiosity, stripped cliff faces and immense plunge pools now make sense as the remnants of former world-sized waterfalls, larger by far than any on Earth today. Massive ramparts and box canyons, once a mystery, are scars of cascading water roaring across what is now dry plateau. These events happened not over millennia, but over hours and days, with the landscape transformed in a geologic instant. The consequences still define the land. The Scablands are studded with deep potholes, nicknamed pothole lakes, and isolated boulders left stranded far from any modern source. The spectacle can be seen from space, vast ripple marks and streaked badlands, evidence of catastrophic events whose scale dwarfs any present-day flood. Recent excavations turned up new trace fossils, animal burrows sealed by silt, bits of preserved plant roots in scoured soils, even fish bones left behind as makeshift lakes dried. LiDAR scans have pinpointed hidden channels buried under the grasslands, echoing the ghosts of rivers that ran for only days or weeks. This growing body of data paints a harrowing scene. overnight rises, forests ripped away, land remade as water drained away, ready for the next cycle. What remains to be learned from this tortured terrain? Could there yet be hidden evidence of even larger floods, or of how life survived on stranded islands and cliff tops? If water can change the land so completely, what other hidden forces, silent and waiting, could do the same? The tectonic spring, Cascadia's looming threat. Under the calm of coastal forests and languorous rivers, a deeper hazard lurks: the Cascadia subduction zone. Once a distant threat in the public mind, new research in 2026 positions this fault at the core of regional geoscience. This is more than a crack in Earth's crust. The Cascadia zone marks the boundary where the oceanic plate slides beneath the continent, a process called subduction, marked by intense friction and stress accumulated over centuries. Occasionally, this stuck interface slips catastrophically, producing some of the planet's largest known earthquakes, magnitude 9 events capable of reconfiguring both sea and land. Offshore mapping, aided by sonar and deep drilling, brings new clarity to this arc. Scientists now recognize a braid of faults, some parallel and some branching, any of which could give way in sequence, or all at once. Modeling suggests the possibility of the entire offshore region rupturing in a single colossal event, a megathrust quake whose impact would reverberate across hundreds of miles. Such a rupture could unleash tsunamis and land-leveling tremors. The region, scientists say, is balanced on a locked tectonic spring, strained by slow movement, held by friction, waiting for the moment when it suddenly slips. Even tiny microquakes and modest undersea landslides hint at the ongoing tension, reminding everyone that movement is inevitable, but timing cannot be foretold. Is the system overdue? Could tension persist for centuries more, or is the release imminent? Communities practice tsunami drills and reinforce infrastructure, but the past is written in buried sand, in mud hidden beneath ancient forests, sedimentary records of past great quakes and floods. Drowned ghost forests of spruce and cedar, their stumps preserved by tidal mud since the last great event, provide radiocarbon dates that reveal cycles of disaster and renewal. Seafloor samples, mapped for the first time in fine detail in 2026, show old submarine landslides. Entire canyons collapsed after ancient quakes. And while the ground churns with secrets, the land holds signs of ancient life, wonders from a lost world buried in the state's shifting soil. Ghosts of the ice, mammoths, camels, and fossil worlds. Today, Washington evokes images of salmon, bear, and towering evergreens. But beneath fields and bluffs lies the memory of an Ice Age menagerie. Fossil bed discoveries in 2026 reinvigorate old debates and paint a fresher image of the state's wild past. During the last Ice Age, Washington was not the wintry, empty place we might picture. Its valleys and riverbanks teemed with life. Massive Columbian mammoths, packs of ancient horses, camels related to modern species only distantly, grazing alongside now vanished bison. In 2026, work around ancient lake margins and windswept badlands uncover an unexpected richness. Mammoth tusks spiraled and ground down by centuries of grazing. Camel bones, sometimes fully articulated, preserved alongside Ice Age grasses. Some finds include enormous mammoth molars and metatarsals, now fossilized to stone, their scale a reminder that elephants once walked this land. Exquisitely preserved fossil fish have also turned up in fine-grained Oligocene and Miocene rocks. their details so precise that even scales and sometimes faint traces of vessel structures can be seen under magnification. An accident of sudden burial in quiet, oxygen-poor lake beds. Summer digs uncovered baby mammoth teeth, hints of a thriving and vulnerable population, and fossil pollen revealing the grasses and wildflowers of bygone floodplains. How did camels and elephants manage in what are now rain-soaked valleys and rugged hills? Researchers debate whether climate oscillations, rapid floods, or human hunting spelled their end. What remains is a vivid sense of how quickly life and landscape shifted, and how much is still hidden below ground. Every new fossil, another page in the region's lost history. If time can so transform both land and animals, what traces will today's species and landscapes leave for future discoverers among new layers of silt, debris, or ash? The dance of fire and ice. Nowhere are nature's paradoxes so striking as in Washington's high volcanoes, where fire and ice vie in a rivalry both dangerous and beautiful. In these summits, glaciers and magma are uneasy neighbors, each shaping the other's destiny in unpredictable ways. Mount Rainier, the highest volcano in the Cascades, stands as a snow-crowned giant, its flanks draped in broad glacial rivers, creased with blue crevices and ancient icefalls. Beneath all this, magma pulses and radiates heat upward, gradually melting the mountain's thick ice from within. This sets the stage for a feared hazard: lahars. Lahars are volcanic mudflows unleashed when erupting or warming volcanoes rapidly melt snow and glacier ice. They surge down valleys at astonishing speeds, thick with ash, gravel, and woody debris, flattening everything before them. Communities and forests in lahar pathways face lasting devastation and layers of thick, choking mud. Through 2026, new monitoring technology tracks subtle shifts deep under Rainier's mantle of ice. Scientists scan for changes in glacier flow and for small thermal anomalies, reminders that, even on peaceful days, a contest between ice and fire plays out that cannot be taken for granted. Old lahar deposits at surprisingly low elevations trace fateful events from centuries and millennia ago, with their lines of buried soil evidence of past destruction. Elsewhere, pillow lavas, curved, bulbous basalt forms, crop out along canyons and rivers. They are remnants of a time when all this land lay beneath ancient seas or lakes, and lava poured into water, forming rounded, solidified lobes. These features serve as proof that land and sea, fire and water, have exchanged places time and again. This relentless meeting of extremes, hot magma and cold glacier, ocean and land, creates otherworldly landscapes. Tiered basalt cliffs, lakes stained by both silt and volcanic ash, and deep canyons carved by glacial outburst floods. Beyond Rainier, smaller volcanoes like Glacier Peak and Mount Baker hold their own icy jewels on rugged, wind-blasted slopes. In these places, glacial outbursts have carved new valleys, sometimes even sending ice-laden mudflows all the way down to the lowlands. Everywhere in the high Cascades, each new layer of drift, pumice, or mud records the memory of alternating crisis and calm, a continuing cycle of threat and renewal. Lava floods, the Columbia River Basalt Group. Astonishingly, Washington's greatest eruption was not an explosion or sudden crater, but a series of slow, immense floods, of lava, not water. The Columbia River Basalt Group, ranking among the world's largest volcanic events, is written in the stair-stepped cliffs and broad plateaus of central Washington. Unlike classic volcanoes that build cones, the Columbia basalts are the result of fissure eruptions. Cracks opened in the earth, and lava oozed repeatedly, layer after layer. Over millions of years, flows sometimes miles wide rolled over valleys and hills, filling old riverbeds and transforming everything in their path. Some single flows traveled for hundreds of miles before cooling and hardening. In river-cut canyons, Yakima, Snake, Columbia, these ancient events remain plain in the tiered cliffs, each band a testament to past outpourings. These floods were gradual, persistent, the earth bleeding out, changing the landscape layer by layer. Geochemical studies in 2026 mapped these flows more precisely, tracing ancient vents into what is now eastern Oregon and beyond. Analysis of soils, fossil forests, and wetlands sandwiched between basalt layers narrows the timeline of eruptions, revealing lost ecosystems blinked out, then re-established. Standing atop a cliff near the Palouse is to stand on millions of years' layers, paradise and cataclysm, survivor and burial, stacked in a vertical diary. What drove these eruptions, and what finally quelled them? Will such scale ever occur again? The lesson, perhaps, is that Earth can remake itself not just violently, but also relentlessly, steadily overrunning the familiar and raising up strange new forms. A living laboratory, Washington's layered wildness. The discoveries of 2026 cast Washington's story in almost mythic terms. Where else on Earth do such forces meet? Where a chain of volcanoes rises over flood-ravaged plateaus, rivers slice landscapes in a matter of days, mammoths once marched in the shadow of glaciers, and lava flows stack their silent evidence for millennia. Here, the memory of the Missoula Floods collides with activity at Mount St. Helens. The ground wears scars of disaster from both fire and ice, as recent as this year and as ancient as the first lava flows. The Channeled Scablands rake claw marks across the state's map. Fossil pillow lavas sit perched in green canyons, reminders that land itself has been remade time and again. Above all, Washington is a place where nothing disappears, only hides. Magma pulses below the Great Peaks, volcanoes bide their time in the clouds, faults and fractures strain silently, and bones of lost creatures lie only inches beneath the plough or trail. Each feature speaks to another time. Forests stored as petrified wood atop basalt, ancient streambeds marked in gravel, stories etched into the very stones. What comes next? In this state, stillness is an illusion. Even the most placid vista may be writing its next page. Tectonic plates grind forward. Magma accumulates by inches. Rivers and glaciers reset the clock with every surge. Each season offers a new test. Each year, a chance to glimpse the forces that never sleep. So look again at those green peaks and wild rivers, the broken canyons and quiet groves. Beneath it all, Washington hums with tension, memory, and the promise of change. In a land where camels once wandered and volcanic floods rewrote the landscape in days, the next revelation may fall with the rain, or surge skyward in a white cloud above dark trees. What waits beneath the next morning's sun, or inside the next tremor? The only certainty is that Washington and its science will never rest for long. This is not a finished creation, but a shifting tapestry where every secret hints at more discovery just beneath the surface. Stay curious. Here, the wildest stories are those still waiting to be revealed.